Today, we're going to unpack a method that treats mathematics not as some subject you have to memorize, but as a whole world just waiting to be discovered. We're talking about Montessori mathematics.
So let's just start with a question. What if learning about numbers and quantities and all that stuff, what if it felt less like a chore and more like an adventure? This, right here, is the fundamental problem the Montessori approach is trying to solve.
It all starts with this foundational idea from Dr. Maria Montessori herself. The hands are the instruments of man's intelligence. And look, that's not just a poetic phrase, it's a scientific observation that the entire method is built on. The core belief is that true, deep understanding, well, it begins with your hands, with physical interaction.
What's so brilliant about Montessori math is that it's not just a collection of clever teaching tricks. Nope, it's a complete system, and it's built on this deep respect for how a child's brain is naturally wired to learn, by starting with things they can actually touch and hold, and then moving to the abstract ideas.
This brings us to the single most important rule in Montessori math, what's called the sacred sequence: concrete, then pictorial, then abstract. A child first has to feel what 1,000 is by holding this heavy, clunky cube of 1,000 golden beads. Then, maybe, they'll draw it. And only after they have that deep physical understanding do they work with the symbol 1,000. That progression, it's completely non-negotiable.
Now, this whole philosophy, it actually extends to the room itself. A Montessori classroom isn't just a room with materials. It's a meticulously prepared environment that's designed to build independence through something called freedom within structure. And you can see exactly how that structure works here. Every single material has its own specific spot on the shelf, and it's all arranged logically, from the simplest concepts to the most complex. Now, this order isn't for the teacher's benefit, it's for the child. It creates this predictable, almost like a map, for their learning journey, and then empowers them to choose their own work.
So what happens when a child makes a mistake? This is a huge difference. In a more conventional classroom, the focus is often on the error, right? No, that's wrong. But in Montessori, the materials themselves have what's called a control of error built right in. If the puzzle pieces don't fit, the child knows. If their answer doesn't match the control chart, they discover it themselves. The goal isn't to get them to comply. It's to help them build the confidence that comes from self-correction.
Okay, so now let's look at the specific teaching method they use to introduce pretty much every new concept. It's this elegant and honestly deceptively simple tool called the 3-period lesson.
The real beauty of this method is how simple it is and how little pressure there is. Period 1 is just naming. This is 7. All the child has to do is listen. Period 2 is about recognition. Can you show me 7? So they can prove they get it without even having to say the word yet. It's only in period 3, when they are totally ready, that they're asked to recall the name. What is this? And if they hesitate, you don't say wrong, you just cheerfully go right back to period 1. The whole point is to give them information, not to shine a spotlight on failure.
So, with that philosophy and method in our back pocket, we can now look at the whole journey. What does this actually look like as a child grows? It's a path through all these different materials, where each one lays the foundation for the next, taking them from simple counting all the way to complex algebraic thinking.
This timeline gives us a kind of bird's-eye view. It all starts with sensorial exploration as a toddler, playing with things, feeling concepts like size and weight. Then, in those primary years, from ages 3 to 6, a child uses those famous golden beads to physically build the decimal system. By lower elementary, they're using materials to understand why multiplication works, not just memorizing how to do it. This deep, concrete foundation is what lets them just confidently launch into abstract thinking in the upper elementary years.
These materials really show you the long-term genius of the system. A child doesn't just learn about the decimal system. They hold a tiny little unit bead, a 10 bar, 100 square, and 1,000 cube. They physically see that 1,000 is 10 times bigger than 100. And the binomial cube? Oh, this is the best part. For a 3-year-old, it's just a beautiful 3D puzzle. Years later, they realize they've been physically manipulating the formula for a plus b cubed all along.
Okay, let's bring this all home, because you do not need a fully equipped classroom to bring the spirit of this philosophy into your own life. These principles are so powerful, and they're totally portable.
One of the most powerful things you can take away is just the language. What we say really matters. So instead of praising the outcome with "you're so smart," we praise the process. I saw how hard you worked on that. It's a small shift, but it builds resilience and a love for challenges, which is really the heart of a mathematical mindset. It's all about the journey of discovery, not just getting the final answer.
And for anyone who's thinking about maybe starting with some materials, you don't need to get everything at once. This table shows a few really common starting points. For example, the golden beads and the stamp game are just wonderful for that 4 to 7 age range because they lay the entire foundation for place value and operations in a super concrete way.
This quote, it really captures the soul of the entire approach. See, the goal isn't to pour knowledge into a child's head. It's to prepare an environment that's so rich and logical that the child discovers mathematical truths all by themselves. They aren't just passive receivers, they are active builders of their own intelligence.
And that leaves us with a final thought. If we shift our perspective from teaching math to revealing it, how does that change the way we interact with our kids? Not just in math, but in all learning. How can we prepare their world so they can discover the brilliant mathematician that already exists inside every single one of them?